You know that feeling when a big storm rolls in, right? The sky gets dark, you hear that deep rumble of thunder, and then, bam! That incredible, almost scary flash of light tears across the sky. It is just one of nature's most awesome displays. But have you ever really stopped to wonder what is actually going on up there? Okay, let's get into it. So, what's really creating that classic, jagged, forky bolt of light we all know? It's a question people have been asking forever, and the answer, well, it's actually simpler and frankly a lot cooler than you might think. All right, so before we jump into the nuts and bolts of how it all works, let's just take a second to really appreciate the massive scale of this electrifying show. At its very core, lightning is really just a gigantic spark of electricity. But when I say gigantic, I mean it. A single bolt can stretch for miles, and of course, it's followed by that unmistakable and kind of unsettling sound of thunder. And its power is no joke. Now, here's something that might surprise you. About 90% of people who are struck by lightning actually survive. But that does not mean it's a minor thing. The amount of energy that passes through a person's body can cause really serious long-term damage. It just goes to show you the immense force we're dealing with. So how can we possibly get our heads around something that powerful? Well, it all starts with an experience that I'm pretty sure you've had. Come on, you know exactly what I'm talking about, right? You're walking across a carpet in your socks, you reach for a metal doorknob, and zap! You get that tiny, surprising little shock. Now, believe it or not, that little zap from the doorknob is basically a mini lightning bolt. No, really. It's the exact same scientific principle at work, just on a way, way, way smaller scale. So, if you can understand that tiny shock, you're going to understand lightning. Let's break down what's happening. As you scuff your feet on the carpet, you're literally scraping off extra negative charges, electrons, and collecting them on your body. Then, when you go to touch that metal doorknob, which has a more positive charge, all those extra electrons make a leap across the gap to even things out. That leap is the spark, the zap, that you feel and sometimes even... Okay, you with me? Now, let's take that same idea and scale it way, way up, from your feet on a rug to a giant storm cloud floating in the sky. Inside a big, churning storm cloud, it's not feet and carpet. It's millions and millions of tiny ice crystals and water droplets all smashing and rubbing against each other. And all that rubbing creates a ton of friction. You see, it's the exact same principle. Your feet rubbing on the carpet builds up a little bit of charge. Billions of ice particles rubbing together in a cloud, that builds up a colossal charge. Same science, totally different scale. Now, the powerful winds inside that storm cloud act like a giant sorting machine. They toss the lighter, positively charged ice crystals way up to the top of the cloud. At the same time, the heavier, negatively charged particles sink down toward the bottom. So now the cloud is totally polarized. It's become a giant battery in the sky. And this is where things get really, really interesting. With that cloud all charged up, something amazing starts to happen down here on the ground. You know that old saying, opposites attract, right? Well, that super strong negative charge at the bottom of the cloud pushes away negative charges on the Earth's surface and pulls up the positive charges. It basically creates a moving shadow of positive charge on the ground that follows the cloud wherever it goes. So this positive charge on the ground, it wants to get closer to the negative charge in the cloud. And how does it do that? It climbs. It races up anything tall it can find. Trees, skyscrapers, mountains, you name it. Anything to shorten the gap to the cloud. And all of this leads to the most surprising, mind-bending part of the whole story. We always talk about lightning striking down from the sky. But what our eyes are seeing, that isn't really what's happening. Okay, so here's the big reveal. First, an invisible channel of negative charge called a stepped leader snakes its way down from the cloud. When it gets close to the ground, a powerful surge of positive charge from below, from that treetop or skyscraper, leaps up to meet it. That connection, that upward surge, is called the return stroke. That is the blindingly bright flash of lightning we actually see. It happens so fast our brains just can't process it, so it looks like it's coming down. So now that we know how it works, let's just try to put its incredible power into perspective with a few numbers. And seriously, these are going to blow your mind. Get this. A single bolt of lightning has the power equivalent of 80 million car batteries. 80 million, all unleashed in a fraction of a second. Or think about it this way. If you could somehow capture all the energy from just one bolt, It would be enough to power a 100-watt light bulb 24/7 for 3 straight months. And this isn't some rare thing. It's happening all the time. Right now, as you're watching this, about 100 lightning bolts are hitting the Earth every single second. And to bring it a little closer to home, in the United States alone, lightning strikes the ground about 25 million times a year. It's just incredible. So what's the big takeaway here? I guess it's that the next time you scuff across the carpet and get that tiny little zap from a doorknob, just pause for a second. And remember, you're witnessing the exact same force of nature that creates those spectacular, beautiful, terrifying bolts of lightning in a storm. You've kind of got a tiny thunderstorm right there at your fingertips.